Welcome to UPSC with VAR. Good morning, good afternoon, and good evening, no matter when, where you're watching this. So, before diving into today's session, let me wish you all a very, very, very happy new year. May this year bring you success, happiness, and fulfillment, and you qualify your dream exam. So, now let's start with a curious number 143. What does it mean? Is it I love you? Well, yes, but today it's something different for you guys. It's the number of days left for your prelims examination. So don't lose hope. Remember, you can do it. Stay focused and give your best. So, what are we studying today? We are studying about artificial intelligence, quantum technology, blockchain, and then facial recognition. We're going to dive into these four topics. So the notes for them will be available in the channel UPSC with VAR. I'll provide the link in the description. You will have a crisp notes saying connecting the dots. Just go look at it. It would be your revision module. That's it. I'll also give you a glance of how it looks at the end of the class. So now, what's an artificial intelligence? What does it do? So it's creation of machines or software which mimics human intelligence. That is, it has human intelligence. So what does it do? It can solve large length programs. So initially AI was just playing games or solving puzzles, etc. But now AI is generating content. AI is helping you to create movies actually. It is helping you study. It is doing everything. In future it can even do more what we have right now. So it can also do the decision making. So everything which a human does is being mimicked into a machine or software. Is called artificial intelligence. So is it only robots? No. So the cars which are automatic, so the facial recognition techniques, the codes, even the this house cleaning robots, or else your Siri, Alexa, all of them also belong to this category of AI. Coming to human and AI collaboration, in what aspects does AI help us? Coming to the supportive mode, when you go to a mall, you will see a security who is checking you. But when you go inside, you want to go to a specific mall. There are some people who assist you. Okay, you want this type of clothes, go to that floor. You want this, you go there, right? So, in order to use those people, it's tiresome to keep so many people. So, maybe AI can help you there. AI can put a chat box there that you can just type in your, okay, I want this, then it will directly navigate you through it. Like go to third floor, you'll have it there, something like that. And this is called supportive mode. It will not replace human involvement, but it will support and enhance your business or anything, your tasks basically. And next, coming to reimaging the business. What is reimaging the business? So you have long work hours. Basically, the scientists, they'll have to solve large theorems which will take them hours, days, etc. So that place, these AI models can help you translate all the theorems or all the data into consolidated form. It will make your time efficient. And the third one is AI replacing humans. While I'll give you an example, while doing complex tasks like you're doing a nuclear testing and you want to observe how is it actually on humans. So there you can put these AI so that whenever there's a nuclear attack happening or something happening, how would people react? Because robots are also thinking what we are thinking, right? So they will, how will they respond when something like that happens? So all of these testings are happening. So for your visual representation, I'll give you examples. See, this is a supportive mode. You go somewhere and you are thinking where to go. So here is a chat box which help you to navigate. So it will be easier for you. And coming to the reimaging business, it will help you solve theorems, it will help you solve accumulate all the data and give you a crisp understanding. And as well as see the nuclear testing, or else there will be some disaster management. For disaster management, when there is a fire, firemen actually go risking their lives in places like this ais can go and help people. Now, what are types of AI? We have three types of AI basically. One is narrow intelligence, which is also called weak AI. Why is it weak AI? So it is a predefined AI. It has only set of limits. Like example is Siri, Alexa, all of them, or else your automatic driving cars. All of them has a very limited scope. So if you tell Alexa go switch on, okay, you'll tell Alexa go bring me something, it will not go and get you something. It has predefined tasks like play music, or else switch on electronic appliances, like that. It has a very limited scope. So it is called weak AI. Coming to strong AI or artificial general intelligence, it can help you do decision making, which is great. It will like, you know, chess, playing chess. See, playing, you might have seen in applications where computer itself plays chess. So what happens there is, there will be no predefined, yeah, they will have set of rules, but they'll not have predefined steps, because based on how we are playing, the system should also play with us. So this is where strong AI comes into picture. And the third one is artificial super intelligence, where AI will surpass humans. Let's see the visual representation again. So this is the weak AI. You can say it Alexa, Siri, Amazon, Echo, anything. It has very limited thing. And also your automatic cars. Right now Tesla is bringing out automatic vehicles. So automatic vehicles, they also have a limited this thing. So they will not go to a shop and get you something. They will just take you on a road. And next, the strong AI, which is they'll play chess similar to you. So they'll use the same intelligence as humans. And this Chitty the robo, anybody who have seen it, uh, this robo actually surpasses human intelligence and creates its own world, which is dangerous, but it can also be fruitful if used in a good way. Never say never. We'll see what will happen in the future. And the next is the main core of your artificial intelligence. So we'll see we have already seen what's artificial intelligence. We'll see what machine learning is, artificial neural nodes are, and what is deep learning. You don't have to go deep inside. So I'll clear the basic concepts which will help you for your prelims, because we are doing prelim specific course right now. So what's artificial intelligence? We have seen that creating machines or algorithms which mimic human intelligence. So what's machine learning? You will have a large amount of data, like either be it from books or be it from your internet, anywhere. It will accumulate a lot of data. The data is like huge and very huge. So all of this machine learning will accumulate, and it will try analyzing the linkages between all of them. Okay, so basically, if you want what's machine learning is, without explicitly programmed means without being exactly programmed, it will learn from the data. Okay, coming to what's artificial neural nodes and what's deep learning, they both are subsets of machine learning. We'll see how. Okay, this is artificial neural network and this is deep learning. So when you see artificial neural network has few layers. So whenever you give your input, It will go through these layers and it will come outside. Same here also. But what's the difference? It's the number of layers. So if you get it if you ask a AI a simple question, it will go through these artificial neural networks and it will solve your question and you'll get the output. But when you have a very very complex question which requires a lot of time and lot of data, that time that time deep learning will come into picture, where it will analyze through layers and layers and layers, and then the output layer will come. So it will have lot of hidden layers compared to artificial neural node. So basic difference is artificial neural node has little layers, deep learning has more layers, simple and complex. I'll also explain with examples. Now this is a artificial neural node. You have put an input that what is this animal. So with some predefined inputs, it will analyze its little face, and already data is there, no? Like what animal specifications are, because machine learning has huge number of data. So it will take all of it. It will go through its hidden stages, and somewhere it will get the answer called cat. Done, you got your answer. Now what happens if you put a face and ask whose face is this? See, cat, through even though it has different breeds, we have similar annotation that this is a cat. But coming to humans, you can tell that this is a human being very easily, but you cannot tell who is it very easily. For that, it will have to measure your face surface, your lips contour, your nose, your eyes, from forehead to chin, the distance, everything it has to analyze, which is very deep and complex. For that, artificial neural nodes might come till here and it will get stuck because it will not be able to process that much information. Then what happens is, then deep learning comes into picture, where it has many layers, and with the help of all the layers, it will give you a final output. Best example for this is ANN. You can put fingerprints, and then deep learning you can put facial recognition. Why? Because facial recognition, as I said, you'll have to measure all of these. But coming to fingerprints, it's just the, what we say, the deep lines. Just if you analyze that, it would be okay for it. So this is basically your ANN and deep learning. The main thing is ANN is inspired by our brain. Just like our neurons, this also has nodes and it's interconnected. So yeah, see, it's inspired by brain and they are interconnected and they recognize patterns and solve problems. Deep learning, it's also a subset of machine learning, but it has multiple layers when vast amount of data has to be there, like image recognition, natural language processing, all of these use deep learning. So even in machine learning, you have three types of learning. One is supervised learning, that is, it's explicitly programmed. It will already tell that, suppose if you ask 2 plus 2, it will not go deep into it. It will already have the data, 2 plus 2 equal to 4. Super. Next, what is unsupervised learning? So now 2 plus 2 is equal to 4 is a data which is a general question, so it will have, that is from the labeled data. Now you have asked it a big question like 2 plus 3 plus 15 plus something something. It's your own question. For this, it will identify the pattern and it will try solving it. That is called learning patterns from unlabeled data. Coming to reinforcement learning. What is reinforcement learning? So here there's a term called rewards and punishments. So whenever a task is done properly and you get a correct output, it will have a little reward. So whenever the output is wrong, then it will get a punishment, so that it will learn from its mistake and it will give feedback to itself and then recheck, and then generate the answer. This is how machine learning types of learning of machines. And next, what are the key components of AI? How does an AI work? With a simple example for you to understand in the real time, I will give you an example of ChatGPT only. So recently we have been listening about ChatGPT a lot. So people who do not use ChatGPT till now, it is something where you ask it a question, it will analyze your question, and it will give you a output. That's it. It is like talking to a machine. Now what are all of these? So machine learning and deep learning we already saw. It deep machine learning is it has lot of data, and deep learning is it will give you your answer, right? Now what is natural language processing and what is computer vision? So computer vision is nothing but it allows the machine to understand the image, and it will recognize the image, and it will give inputs to its deep learning and then give you an output. So computer vision is nothing but it will visualize the information like images and videos. Okay, what is natural language processing? So now you when you go to ChatGPT, you ask it, right? You ask a question. So the way your voice goes in and the words go in is nothing but natural language processing. So now you will ask a question, what date is today? So as you know that all our computers will not understand English, Hindi, Telugu, Marathi, nothing it will understand. It will understand only 0101. So what natural language processing does is it will try understanding our human language. That's it. Remember that it will understand our human language. Now we'll go deep into it. We are going to see natural language processing a little deeply. Why? Because ChatGPT is being in news all the time, or else ChatGPT can also be called generative AI. So it's being news everywhere because all apps are actually implementing generative AI into their systems. So we have to understand a little bit. That is also very easy, I'll tell you. So earlier in 1970s, something like that, don't remember the year, it's just for a reference. So initially what used to be there is it is rule based approach. What is rule based approach? The coders used to write rules of grammar and they will give it to the computer. So whenever you tell something, it will analyze each word and it will see if grammar is correct or no, and then it will understand and it will give you an output. Next is statistical method. So what does statistical method do is whenever you give a data, so in statistical approach, a large amount of data from books is already kept it kept in its memory. So we just like our machine learning which has large amount of data, in statistical approach also from books we have put data into it. Now what it will do, so if you will ask a question, what is today, is it good? So the answer should be today is Tuesday and it's good. So what the statistical approach will do is it will analyze two words. So it will analyze what is and then is today, and next is it good, like that. But what happens is when it comes to it good, it will forget what is, because memory is too low. It will only remember 2 to 3 words. So this happened. So with all of these backdrops, then came in 2000 to 2010 neural networks came into picture, which is called recurrent neural networks. What is a recurrent neural network means? Memory has been introduced for the first time. So there's no limit to remember words, but it can handle 5 to 10 steps per head. Here it used to handle 2 to 3 words per step. No, here it is 5 to 10 words per step. Next, what is conventional neural networks? Conventional neural network was first for processing images, But later it got shifted into text as well. But even this also, it had few backdrops like remembering large amount of data. It had a issue. So then next came the evolution towards attention and transformers. What's an attention mechanism? So whenever there is a sentence given, it will put attention to everything. So first there is an example like, I like apples from Jammu and Kashmir. So this is a statement. It will analyze like apples, Jammu and Kashmir. It will omit words like these so that it will understand, okay, it will, somebody likes apples from Jammu and Kashmir. It will framework. From this, we also got an evolutionary framework which is called transformers. So coming to this is a huge change where, you know, it actually uses this attention mechanism, all other mechanisms, they put all together. They have put transformers where data is processed all together. It will process everything together and then it will give you the output. So what happened here is, these were basically used for text summaries or writing small books, or else redefining your paragraphs, like that. So it had only simple things. So whenever you put data, it will regenerate it and then give you your answers. So transformer model is nothing but it will generate all the data parallelly and simultaneously. Okay, then came the large language models. These large language models are today's generation, your Siri or Meta AI, everything is based on large language models. So this is basically formed on the transformer model. In transformer model also you have two things. One is encoder and decoder. Encoder is like, it will generate your response. Decoder will see if your response is correct or no, and it will check, it is basically checking the authenticity of your answer. It will check whether it is correct or no. And then coming to uh, large language models, what it does is it will generate the text. So it will, from scratch it can generate everything. So the most important topic, generative AI or conversational AI. So this can be defined as nothing but, you want a text, you want an image, you want a music, you want anything from scratch. You just tell that, I want this, it will bring it to you. The main example is ChatGPT, or everybody now uses WhatsApp. So you have Meta AI. Meta AI basically does not give you uh, images or anything, but it will actually reply to your questions, reply to your queries, right? So advanced models like generative, that chat gpt, they'll even form images for you. There are even applications which form videos for you. So this is what generative AI means. So it is capable of creating new content like text, image, or music. Yes. So what are used in this? As I told you, transformer based LLP models, the natural language processing. Remember again, so what all is used here? Natural language processing. For natural language processing, you need deep learning. Okay. And then there's generative adversarial networks. So it is actually having two tools like generator and discriminator. It creates new data and it will understand the difference between a real data and the generated data. And what's variational encoders? It's like, it will, so whenever you give some data, it will compress it, it will understand what it is, and it will give you the output. It is called variational autoencoders. Coming to how AI works. AI first collects the data which you give, and then it will process it, and based on the AI structure, like AI, machine learning, if you want, they'll go to artificial neural nodes, and then deep learning, and then finally the output will be coming, and then if it's wrong, you have the feedback mechanism. Same data collection, pre-processing, model building, decision making, and feedback. So we have read all of these, right? So there can be few questions where they'll ask you like this. So this is, something called Sara. Before explaining this, I'll tell you. So there'll be a question, right? Recently, there's a term Sara being seen in use. What's Sara? And you'll have your options: AI, quantum technology, blockchain. What's your answer? So it's AI. So what's SARA prototype? So World Health Organization has given a AI tool which is called SARA. So what does it do is, whenever it will predict your answers for healthcare. So any questions or any queries regarding your health, diseases, preventive cares, everything is here. So recently it has released it. So remember it. So the topic here is quantum technology. I think I have put my lot of efforts to make you understand in a very simple and easy manner. And while explaining, I loved this topic as well. Hopefully, you'll understand it clearly. So, what's quantum technology? Quantum technology is nothing but it uses the principles of quantum mechanics to create advanced systems. So, what is quantum mechanics? Quantum mechanics talks about atomic and subatomic particles. That is microscopic particles. You cannot see them with your naked eyes. You should use your microscope to see. So let's take an example. Do not put pressure on your mind for non-science students. Just understand that you have a table. So when you zoom and you finally zoom, no, there will be particles like this. Okay, they are called atoms. So any of your objects which you see beside is made up of atoms. So in atoms also, inside you will see nucleus and then electrons revolving. Okay, so now what is our problem here? So these are called subatomic particles. That is, the protons, electrons, all of these are called the subatomic particles. Now we will see what's classical physics versus quantum physics. So basically our classical physics is like whatever we see and the rules which apply. So Newton's law, where everybody know, for every action there's an opposite reaction. So you throw a ball onto a wall, it will come and hit you back. So this is a classical physics example. You're walking and you're not falling down. Why? Gravity, friction, all of these. All of these are classical physics. But what is quantum physics? As I told, every object around you is made of atoms, and inside that atoms you have subatomic particles. So reading about them is something called quantum physics. So before understanding all of these, I would love to tell you an example which I created for your understanding. So here, this is a house. A mother tells her son that, I want 3 items from supermarket. So basically she tells, I want 1 item from supermarket. She want atta or else wheat flour. Okay? Then what this guy asks is, I'm going out for you, so I will take some chocolates and some biscuits also. So she'll tell, okay, go. Fine. Now what happens is, this guy goes to the market. So immediately he will get 6 hands. Okay. Normally what I do or what you do is, you will go to the supermarket, one by one item you will pick First you will pick your dairy milk, and then biscuits, and then atta, right? But this boy uses his magical powers. So at a time he will get 6 hands. At a time he will pick everything from the shelves. Like he'll take dairy milk at a time, biscuits at a time, atta at a time. So at one single time he is doing different things. So again I'm telling you, at one single time he is doing different things. And the next one is now okay, but first of all he will have to see, no, like what are the items I am picking. Super. And because without seeing he cannot pick everything in the supermarket. No, he only want 3 things. He want biscuits, he want dairy milk, he want atta. So he will see and he will do. And while seeing also, he will check with his hands, like, hey, is parleji here? Hey, is biscuits here? So he will keep on checking all of them. So what happens is, if suppose already this hand saw the dairy milk and it took, then this hand automatically it will search for atta and biscuits. It will again not search for chocolates. Okay, over. So remember the example, this mother told him to bring something, this he told I will get 2 more, and normally me and you will go to supermarket, we will pick one by one, but this guy is a magical person, so with all of his hands he will pick all at once, and then he will check with his eyes that whether all of them are correct or no, and then with while also taking them, he has these hands, they'll be checking each item, and once one hand picks dairy milk, the other items automatically will understand that okay, dairy milk is picked, we'll have to search for the other 2 items. So this is the story I would love to tell you. Over. End of the story. Again we will come, but till now it is the end. Now quantum mechanics, you don't have to understand it very deeply, but I'll tell you one thing. What is wave particle duality? So this is a wave. So these are okay, you see in the night, evening, when birds are going, they go with a very disciplined way, in a very nice format, like they will not even see what is happening and all, they will go like this, right? So now from far away if you're seeing, you will see that okay, there's a line going, oh, what is it? But once you come near and you start observing, you will see, oh, it is birds, not a line going. Am I right? Same way, we have wave particle duality, like particles. So in this case we see birds as particles. So particles can behave both as waves and both as particles when observed. Okay, till observation it can be a wave, but while observing we will understand that okay, it's not a wave, it's particles which are going in one specific direction. So that is what wave particle duality is. That is, the particles, the atoms and the subatomic particles, they will exhibit wave like behavior, and while observed it will put particle like behavior. Okay, super. One more thing, what is quantization? Remember that whenever energy is released, it's not continuous, it is in a discrete form, like packet, it will get released. Remember what's quantization? Energy released in packets, not continuous. So energy are discrete and they are not continuous. What is superposition? Now come, let's go to the supermarket example. So here, that magical boy, so here we are referring it as quantum system. can exist in multiple states simultaneously. That boy actually picked with all of these hands all at once at one single position. So it's called a quantum system can exist in multiple states simultaneously. Okay, simultaneously he can pick everything, so he can exist in all states, which normally I and you cannot be there. Next, uncertainty principle. What is uncertainty principle? So you see a car, it's going in very much speed. Okay, so it's going maybe 200 kilometer per hour, which is not practical in our roads, but still he's going in 2 kilometer per hour. So simultaneously, can you detect the speed and the position he is? No, right? By the time you want to detect the speed, it will go. By the time you want to detect the position, you will not be able to calculate the speed. So this is what uncertainty principle is. So it is impossible to simultaneously determine the position and momentum of a particle. Same happens with the particles. You cannot determine its position as well as the speed at the same time precisely. That's it. Now what is entanglement? Here I told you, this hand, okay, this hand got dairy milk, am I right? So immediately these two hands will understand that, okay, I need to see atta, okay, I need to see biscuits, because these are interconnected states. Okay, that is what entanglement means. Particles become interconnected such that one influences the other regardless of distance, regardless of time. Not time, regardless of distance. That is, though the hand is up, it is in middle, it is in downside. Once a hand gets its dairy milk, the other two hands will automatically understand that, okay, I got the dairy milk. Now I will have to search for atta as well as biscuits. I think I tried to make it clear and a little simpler. Now we will start seeing the applications. So these are the 5 principles basically quantum mechanics uses. We will implement them in our applications as well. So first we'll see what's quantum computing. Now in normal computer we will have 0, 1, like both our hands, right hand, left hand. Okay, but now we are using quantum computing, big entanglement, superposition, big words you are using, no? Then you should have something here. Just like that guy has magical hands, so these are binary bits. Okay, and these are our hands. So just like that guy has magical hands, quantum computing has quantum bits. Just like binary bits, we have quantum bits. What are quantum bits? So it can be 0, it can be 1, and it can be a superposition. That is, it can be both at once, 0 and 1 all at once. So with this what happens? Your speed accuracy improves. So if I will go to a supermarket, I will have to pick chocolate, I will have to pick atta, I will have to pick Parle-G. It will take 3 minutes for me. But with this magical hands guy, will take everything in 1 minute. Efficiency is being improved. So qubit is nothing but it represents the bits, that is 0, 1 and 0, 1, which is the qubit superposition, which is in superposition. That is, it is in both states until it is measured. Remember this word, until it is measured. So until this is measured, it can exist in both the states. For example, f of x equal to x square. Don't get, frightened by seeing this equation. Just I am saying f of x equal to x square. Find f of 3 and f of 4 plus f of 4. So for this what you have to do? 3 square plus 4 square. What is it? 9 plus 16. 25. This is what a traditional computer would do. Now, I don't have magical hands, so I am writing like this for you. What happens here is, in quantum computing, as it has magical hands, the superposition thing, it will calculate everything at once, like f3, f4, everything at once. It will directly give you answer. So it is improving your time efficiency, your accuracy, everything. So this is what qubit means. Just like the binary bits in normal computer, you have qubits in uh, quantum technology. Next, what is quantum interference? Now, here I told you, right? This guy will check with his eyes that am I doing it correctly or no. If he is doing it correctly, he will throw that object and he will pick another object, right? In the same way, so where is it? This is where quantum interference is. Quantum interference is nothing but it will check whether the answers are correct. If no, it will cancel out the incorrect ones. Okay, done. Next, what's quantum gates? So, it will operate on qubits as we saw. Now, so totally, finally, this guy should have dairy milk, atta, biscuits. Now, in the end counter, this billing counter, he will again check no whether all of these three are correct or no. So for that, in traditional computers, you will have using and or gates. In the same way as we are using quantum computing, we use quantum gates in order to verify the logics that are all correct or no. Okay, what is quantum coherence? Okay, you might be a very good guy, I am not, so I will forget atta. Finally, I will forget atta. I will pick cool drink this time. But your mother asked you to get atta, which is very important, right? So for that, what you need is discipline. So you should have your discipline and understand that, okay, I have to get them, I have to get them, I have to get them. That is where quantum coherence comes. So if you're not disciplined, you will tend to go and pick other things rather than the wheat flour, right? So this helps maintain our magical hands, stay in the correct place for your computation. That is, it will help us to stay in that place for correct picking up of things. Why? Because we are kids, and when going to supermarket, we always tend to deviate from what we have to buy. We will get everything, we will forget what mummy tells, we will come back. That is where quantum coherence comes into picture. And then next is entangle. Sorry, these two I will explain in the next slide. Already this slide became like this. Next one is entanglement. As I told you, if there's a change in one place, it will immediately the other place will get affected because these two are interconnected very, very strongly. Okay? And then quantum supremacy. What's quantum supremacy? The traditional computers would take 1 year to complete a task. Quantum systems can actually complete it in maybe 10 minutes to 20 minutes. It's just an example. That is, it is superior to your traditional systems. So that is called quantum supremacy. I hope I am clear. So while quantum computing, you use all of this. That is qubit. That is, it exists in all the states all at once simultaneously. Quantum interference, it will check whether the answer is correct. If no, it will eliminate the wrong answers. Quantum gates, it will check whether all the logics are correct and the given answer is correct. Quantum coherence, uh, this one in this state, qubits are very, very, very sensitive. Like even a small disturbance happens, it will forget everything. So quantum coherence, that is, in order to maintain the qubits in that right state, we want quantum coherence. Entanglement, two objects are connected in such a way that one will automatically affect the other one. Next is quantum supremacy. Just like I told, it is superior. Yeah, for entanglement, I have given this picture for an example only. So recently, I think last year or somewhere, I have seen an ad where there will be a girlfriend and a boyfriend. So these two are in long distance relationship. They both will have two watches. So if you poke on one watch, the other watch will shine. This can be an application of entanglement, but I am not sure whether those watches were using entanglement principle or no. Next, let's go to quantum communication. Before going to quantum communication and why do we need it, so this scientist guy is telling this scientist guy something. It's a very secret information. I am standing here, I will trap their phones and I will get that information. I will go put a business, I will become very, very successful. These guys are still here only. Then in order to put an end to this, quantum communication comes into picture. So what's quantum communication? So in quantum communication, the information is sent through photons. Photons are nothing but, they are a form of light which carry your information. Okay. So they are the physical medium for transmitting quantum information. Remember, don't remember too much. Photons are light packets which carry information. So when you see it, you can think of your tube light and you can just see and you can ask it, oh, are you sending me some information? Basically, no. So when I first read this topic, I also thought that, okay, my light is sending me something, I am not receiving it. Photons or the light send information in a controlled medium. Okay, and it uses tricks like quantum key distribution, everything. That's how the basic principle works. So every light you have, it does not give you information. Okay. Now, we will use quantum key distribution. Before understanding it, I will tell you how this actually works. Now, there is a sender and there is a receiver. They both are in different places. This sender will actually quote a message. I want 100,000 rupees. Okay, this is a, just I'm telling, this is a confidential message. Nobody like me should listen. If I will listen, I will go and take that money. Okay. Now what he will do is, he will encrypt it like XYZ. He will encrypt. So a message, you put it into code, is called encryption. So a code, you want to convert it into message, it's called decryption. Remember that, encryption and decryption. So now he will say XYZ, he will put one code. Now what we will do, this code you will transmit into qubits, something like this, and then via your quantum key distribution or the now this will put in, this is called quantum key distribution. Okay, now this is put into photon and is transmitted to this guy. Now this guy received it, but what if I tried hacking here? They should understand no whether I tried hacking or no. Then through normal communication, like this sender and receiver will call each other and say, they will validate the quantum key. Like they'll say, okay, in first position do you have 0? Yes. Okay, in fifth position do you have 1? Yes. In ninth position do you have 0 1? Yes. So if all of them are correct, then they'll say, okay, there is no fraud happened here. But how will it happen? These are qubits. I told they are very, very, very sensitive. So even a small hit has happened over there, it will change its quantum state, and the other person will understand that okay, there is some thing happened to my code. So this is actually leaked to somebody. So I should take care of it. Okay. If all of them are correct, this guy will decrypt it and he will read the message. This is what will happen. Now, for short distances, through optical fiber cables, you will send your photon, that is a form of light. Okay, but for long distances, it is achieved through satellites. This you can see an example like a satellite. So, in order to generate a message, what I want to do is I will initiate satellite that okay, I want to do a quantum key distribution, so you please give me 2 photons. So you're staying here, this guy is staying here. So satellite will emit the light photons, that is the light, to both of your places. Here what will happen is once the photon is coming here, now he will put that qubit directly over here. The key will be, he'll be putting it directly over here. As I told, entanglement principle, the change over here will automatically reflect here, no matter how far the distance is. So it will come here, 0 1 0 1 0 0. So even here also I can do a fraud, or I can do cheating, I can disturb the quantum bits. So if something like that happens, again this will change. So the same process again. Now they will check through the normal conventional way, that through phones or SMS, that in this position do you have this number, in that position do you have that number, and similarly, if yes, then it's done. Okay, but now what's a problem here is, one, qubits are very sensitive, so you have to find a medium where there is nothing which is disturbing them. Okay, that is called spin photon interference, where it will provide a path where these qubits are transferred safely. Right now the nice application is quantum dots interface. You don't have to remember everything, just remember that spin photon interface is like the road which it has to go where you don't have any obstacles, and the road name is quantum dots. Okay, and next, did I tell you this? Oh, the applications. Apologies for this. So applications of quantum computing is like secure communication. What's cryptography? Cryptography is, see, normally I am telling you that a normal computer, if you try hacking it, you will get information very easily. But coming to quantum computing, it's very hard to track. Okay, because it has many functionalities. So you will have a very secure communication here. And as I told, the time efficiency, it can validate the molecules very fastly, and you can have new drug discoveries. In AI and machine learning, you can put it. Even in the financing modeling, I mean, like it will check your portfolio, it can suggest you some things, it can check the share market, it can suggest you some things. So, and then weather forecast with the large amounts and huge amounts of data, it can actually tell you your weather report very fastly. And then, yeah. So what are initiatives by India for quantum? So in India, they are trying to put dedicated labs for quantum research. And there's a QSIM toolkit. We will read it in the next slide basically. And then there's National Quantum Machine. So here, I think I did not put it in the slide, but what's National Quantum Machine is, it will scale up scientific and industrial research and development. Okay, and the implementing agency is PST, Department of Science and Technology. So the duration is 2023 to 2031 basically. And then they also want to initiate the quantum communication network for over 2000 kilometers. And they want to create a computer which has 1000 qubits, as well as they want to improve atomic clocks and magnetometer for nice and good precision results. And mainly they want to create 4 thematic hubs, that is for quantum computing, quantum communication, meteorology, materials and devices. So they want to set up all of these under national quantum machines in this specific time period. And recently there has been a meeting for machine coordination cell. What is machine coordination cell? It will actually it will be an intermediary or else a communication medium for national quantum machine and Department of Science and Technology, because Department of Science and Technology is actually initiating it, but it doesn't have only quantum machine. No? It will have lot of machines. So basically it will think what is happening there. Next latest news. So Bangalore based startup actually innovated secure communication through quantum key distribution. So even our ISRO's Space Center Lab actually created a hack-proof communication system using quantum technology. So DRDO and IIT collaborated and they demonstrated a quantum key distribution over 100 kilometers from Prayag to Vindhyachal. And there's a Mysicus satellite, which is a China's satellite. They enabled the first quantum communication capabilities satellite. And our Ministry and Electronics and IT actually gave a toolkit for quantum circuit simulations. What is a QSIM? So now everybody know there are languages like C language is the basic language. Where will you perform this language? It should have a tool, no? In the similar way, to do quantum computing, you want a tool. Our government initiated QSIM, so it is a tool. And UN declares 2025 as National Quantum, International Year of Quantum Technology. Just so the, just so the topics became so complex, we will do a little easier topic, that is facial recognition technique. So basically, a computer uses algorithm to map unique facial landmarks like shape of the cheekbone, the lips contour, and the distance from here to here, your nose distance, your eyes, your eyebrows, your forehead, from forehead to chin, the distance. Everything is detected and it's converted into a numerical code, because that is what a system would understand. It will put a numerical code. So whenever you input a face, it will detect all of them and it will check with the numerical code, and then it will say is it yes or no. That is what happens even in your phone unlocking as well. So types of biometry could be behavioral, facial and chemical. Coming to behavioral, it will see how you walk, what is your physical attire, like how you dress, what's your dress sense, everything, how your body is, everything, and how you interact with people or devices. Your typing style also it will remember. Okay. And coming to facial biometrics, your eye scanners, while doing that Aadhaar card, they will check your iris scan, and then voice recognition, fingerprint, signature also, that it will identify your writing patterns. Here I think you also have your facial recognition. And then coming to chemical biometrics, it is the DNA analysis and our brain recognition, like how our brain activities are there. All of these are types of biometrics. So why are we reading all of these? Because in news, we have automated national facial recognition system. So this is used by our pan-India police. So it will help them identifying criminals easily, and this is how it is. And then the telecom ministry of communication actually developed AI based facial recognition for telecom. Whenever for your phone sim subscription, whenever you go, they can identify whether you already have sims, or you are if you're not a correct person, or else you're a terrorist. Anything, it can come through your facial recognition. So it is a part of Sanchar Sati scheme. What is Sanchar Sati scheme? If you go to the website, this is basically for your communication devices. It will check on your name what phone numbers are there in your. Is your phone stolen? If yes, the tracking, and if the police tracked your phone, where is it? Everything. So as it is employing a facial recognition technique and lot of data is there, it used the Param Siddhi supercomputer. Remember recently, Ministry of Communication gave a AI which is facial recognition, and it also used Param Siddhi supercomputer. Okay, supercomputers will be read later. So now again we are diving into a topic which is complex, but I've made it very, very, very simpler. That is, before diving, we will see. Now, imagine you have a notebook, and this notebook is not only with you, it is with everybody who has access to this notebook. In the sense, everybody who can buy this notebook, or everybody who is interested in this notebook. So every time you make changes, suppose you draw a apple, or else you draw a mango. Every time you do something, it will get changed, reflected in all the notebooks, no matter what, every notebook. So now what you do is, you cannot edit it. So once you have drawn something in it, you cannot erase it, you cannot do anything. All you have to do is turn your page and again start drawing something else. So nobody can erase it, nobody can delete, even you can't delete it. Okay, so now this system in real time is called blockchain technology. Blockchain technology. So before even understanding what blockchain technology is, we will understand what a digital ledger technology is. So blockchain is a sub part of it. So I am just telling this for reference so that you will better understand blockchain. So digital ledger technology is nothing but it's a database where data is shared, replicated, and synchronized across multiple nodes. So whenever there's a change here, it will automatically reflect here, 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 and here. So it is shared, replicated, and synchronized across multiple nodes and participants. But the best thing here is, even this guy also can change something and it will get reflected. This guy changes something, it gets reflected. So there is no central authority. It is a distributed network. Anybody can be an owner, anybody can be a normal person. So there's nobody who is like, I am taking the central authority. It is nothing like that. Why? Because to ensure transparency, security, immutability. Immutability means for not able to erase anything. Immutability means not able to erase anything of transaction. So initially this digital ledger technology is only for what do we say, transactions only. But later it got into various applications like healthcare, supply chains, etc. So the key features here, as I already told, it's transparent and tamper proof. Nobody can change it. It is secure and decentralized. It will provide an immutable record of transactions. Nobody can erase those transactions. Next, but at the same time, nobody will know who has done it, because your name will not occur over there. If you want, you can, but generally no. So where did all of these come into picture? The blockchain first came into picture. Wait. So we saw what is digital ledger technology, no? So there are subtypes. One is blockchain, one is directed acyclic graph, hybrid digital ledger technology, and holochain. So blockchain is nothing but whenever you do changes, it gets stored in a linear format in blocks. Okay. So they are added sequentially. But in directed acyclic graph, they are the transactions are added in the graph format. And coming to hybrid digital technology, it has both centralized and decentralized one. And coming to holochain, it is basically a local network and it has its own local rules. Okay. So coming to blockchain. So this is actually this digital, it has the digital ledger technology as its roots. But it gained prominence in 2008 when Satoshi Nakamoto brought into picture Bitcoin, the cryptocurrency. This was the first time everybody in the world knew blockchain. So he used different types of other technologies, like the digital ledger, everything else, cryptography, everything he have put into one place and he created blockchain. Now, as you saw what different types of digital ledger technology, we'll see blockchain also. As I told, firstly, that Japanese guy was the first one who did blockchain in the Bitcoin cryptocurrency. Okay. So, what is a blockchain? Again, it's a specific type of digital ledger technology where blocks are linearly connected to each other. And as I told you, all blockchains are digital ledger technologies, but not all digital ledger technologies are blockchains, because you have holochain, you have hybrid, you have acyclic graph. So what does it do? So each block contains numbers of transactions, and for every box you should have a name, right? So that name can be called as hash number. Okay. So every time a new transaction happens, a new block is created everywhere. So there will be no single point of failure or no single point of truth, because if once you change here, for other person also it will change, no? So if your system fails here, it will not fail there. So even if the information is not present here, it is present safely in somebody else's system. So there is no single point of failure. At the same time, truth will not always be in your computer only. It can be in everybody's computer. Okay. So it operates on distributed trust. No individual owns this, and no single person can actually modify it wholly. You should have consent with your peers, and then only you can do it. So now I am telling you that once I change here, here also it will change. What if I put my personal information here? Don't you think it's a problem? Or else this digital ledger technology is very good. Now I have supply chain. I have a shop. Now this is in Hyderabad, this is in Delhi. I bought some t-shirts today, and I want to tell to Delhi's office. So if I use this blockchain, automatically the information gets transferred to Delhi. Isn't it good? It's good, no? So it's okay for shop people. But what if it is healthcare? Everybody in the node will actually understand that this guy has this problem, because once you upload your certificate, it will get reflected in everybody's system. So you have privacy concern. So when this privacy concern is there, that is when we started, uh, you know, separating and making new concepts out of blockchain. So I'll tell you, you have a potato. You will one day you will eat potato rolly. Second day you will eat potato rolly. But third day you will think, when according to your needs, you will either make potato curry or you will make French fries. Am I right? So that is where now we come under Permissioned blockchains. So, what is a permission blockchain? So, only authorized participants are allowed to join the network and perform specific roles such as reading, writing, and validating data. So, this gives you privacy and restricted access. Features are controlled access is there. It will be faster and more efficient because the network is small, and privacy and security is also there, and you can customize you can give one person only read access, person you can give read and edit access both, so it is customizable as well. In what can it be used? It can be used in healthcare, it can be used in supply chain, because I don't want my competitors to know what I want, no. So supply chain, and even in our public services we can use it for schemes and etc. And then even for our pharmaceuticals, you need to manage your drugs, everything, like you're distributing here, so for there also you will do. For insurance also, see, one person is claiming in Hyderabad, one person is claiming in Delhi, same insurance. This also, it can, through this blockchain technology, these insurance companies can actually understand that there's a fraud going on. So even in our grid systems, energy consumption systems, you can use blockchain, permissioned blockchain. So basically, before earlier blockchain applications were mostly permissionless only. Okay, uh, with respect to the privacy issues, and as we are updating daily, then we came into permission blockchains. Uh, yeah, our blockchain technology is consisting of four main applications. So first one is distributed network. As I told you, your work gets distributed everywhere. So distributed network is there. Next is cryptography. What is cryptography? I'll explain. Um so whenever there's a change, a block is created. So suppose the block name is given as ABDC. Who creates this name? It has to be unique for everything. And how is it created? It is created using a method called cryptography. So what it does is, it takes the inside, you will have some data, no, like suppose A to B, there's a transaction of 1,000 rupees. So there's a data inside that 1,000 rupees is transacted from A to B, and it should have a name. Okay, so this is basically the block. You will have information inside, and ABDC will be the name. And how did we get? And 0001 would be the name. Example I'm giving you. So what this cryptography algorithm does is, it will take the time when this block is being created. It will generate some odd alphabets like ABDC, and it will take the transaction details, and together it will create a name. ABDC 0001, 1000 reversed here, and some time, like that it will create a particular name. So what happens here is, once this data is encrypted and it's put inside, and this particular name is generated by cryptography, no matter what, you cannot edit it. Even if you try to tamper with it, other people will know. So even if you have to make a slightest change, you will have to again create a blog, and you will have to make the specific changes. So what it does is, it will help not tampering your information. See, it secures data by encrypting it and giving it a hashing. Hashing can be called the naming of block. So once data is added, it cannot be tampered. And next is consensus algorithm. We will see it in the next slide. So next is peer-to-peer network. So if I do a transaction, I validate it. Somebody else will validate my transaction, and they will put a block. Every time different person will validate the transaction. There will never be a single authority who will validate it. Okay, but in permission blockchains you can have a central authority where they are giving permission to few people. But here, every time a new person is validating your transactions. So what happens here, this is called peer-to-peer network. There will be no central authority. Okay, next is consensus algorithm. Before telling everything, so now I will try to explain you what is proof of work and what is proof of stake in detail. So this is just for understanding purpose. I'll explain it in a very simple way. Try understanding it. So now Sukoshi, the Japanese guy, actually created a block. So as I told you, inside you will have information, you will have bitcoins. So basically I think it's 21 million bitcoins inside. And he gave a name, some name. And inside he also gave the names of other uh, hashes also. So what happens is, there's a process called mining. So how to take out these 21 million outside? That is where mining comes into process. So this term is called, in order to take the money out, there's something called mining. Now, this Japanese guy first made a transaction from him to some person S. Okay. Now this transaction will go into some pool, that okay, this transaction is made because only one transaction won't be made, no? Like that 10 example 10-15 transactions are made. Now I also am interested in blockchain technology. Now I will go and I will validate this transaction first, that whether this Japanese guy has enough amount to send to this S guy. If yes, I will say yes, it is a correct transaction. But now I have to add it to a block. Am I right? So how do I know what is that block name? So I have to start solving puzzle. Puzzles means not our normal puzzles. It will be very hectic, where you have to find the hash name, that is the block name. That is a rigorous process. So don't go into it. Just understand that you will have to solve puzzles. These puzzles will require a lot of computational power. Our normal computers, normal phones cannot work. It has to have a large setup. So it is very tough. The person who actually cracks this puzzle, so approximately just imagine 1,000 persons are working on the same puzzle. Okay, now I got the puzzle right first instant only. So I will drop that, okay, I got this puzzle right, and I will send the information, and I will generate a block, and few people, other people will validate, yeah, this I think this step is correct, and finally he got the answer. Then finally my blog is created. Like, am I a mad person that I am only doing this for knowledge purpose? No, right? Just because I validated this transaction and I solved the puzzle and I created a blog, I will get some reward. This reward is nothing but I will get bitcoins. Bitcoins right now, one bitcoin in India is approximately 80 lakh rupees. Okay, so what happened here? First of all, there's a block. You have to validate a transaction and solve puzzles. Then, as a reward, you will get a bitcoins. Okay. Now, as we spoke earlier, quantum computers, right? If quantum computers will come into more people, these problems can be solved very easily. So yeah, now what if quantum computer comes and I will solve everything in 1 minute? That can be a case, but what happens is, whenever you're solving the problems very fastly, the complexity of puzzles will also increase simultaneously. Okay, and what if this 21 million bitcoins are over? If over, it's over, that's it. The next thing is, um, for every 4 years, the amount of rewards get halved. Why? Because if they keep on giving you coins, it will get over, no? So for every 4 years, they get halved. So initially, if they are giving 100 coins, after 4 years, they'll give you 50 coins, like that. Okay? Excuse me. Um, so this is proof of work. What is proof of stake? So we have few disadvantages here, right? That you are taking more effort, everything like that. Now coming to proof of stake, what happens is, so this is an example of Bitcoin. You will get a nice example here. I wanted to share it with you. The first Bitcoin transaction, how is it used? 10,000 Bitcoins were used to buy pizza. The first thing, when nobody knew how Bitcoin's value is going to change, they used 10,000 Bitcoins for buying a pizza. Just imagine and convert it into our Indian money. You will understand. And next is point of stake. I mean, proof of stake. So what happens here is, same transactions happen. It will be in the transaction pool. Here, the person who completes the puzzle first is a validator. Like many people are validators, and the person who completes first gets a reward. But here, in proof of stake, there will be many people. Okay. And the person with highest stake, that is, stake means the person with highest coins, he will tell that I have these many coins, so I think I can be a validator, I want to be a validator. And the algorithm picks this guy as a validator because he is putting 300 coins and saying that I want to be a validator. So this will be in hold for some time, and if he validates everything is correct, these are sent back to him, and some transaction fees also is sent back to him. Okay. So a person with highest stake is put as validator here. So he will validate the transaction. He will generate a block. So here rewards won't be there because you did some work. You will get transaction fees. So what happens here? Why is it more efficient? Here, 1,000 people are working on the same puzzle. So it is creating more pollution, everything, more efforts, everything. But here, one person is chosen directly. So is it always the amount of money? No. Sometimes the algorithm also chooses based on age, or else based on certain criteria that this guy has been for a long time, sometimes like that. So validator is chosen from people. So what happens is, it is more easier. Now, okay, so this is proof of work basically. I don't know how I did it. So the mechanism is process of mining. Miners solve complex problems, validate and add block to the blockchain. Miners, as they start using more nice computers, the difficulty will also increase. And once the problem is solved, it gets added to the blockchain and miner is rewarded. Like these many coins of bitcoins can be given like that. And controllability, this is a main point. So what if I want to control the whole blockchain system in proof of work? So suppose there are 1,000 blocks, and I am telling you, for creation of one block only, you require huge amount of computer services. But In order to control the whole blockchain, you should have 51% of the network computational power. Like now 1000 suppose 1000 blocks are there and 1000 people are there, so you should have the power of a computer approximately with 500 computers put at once, one single computer. That much computational power you should have, which is very difficult and expensive also. What you In order to put this computer only, you will require large amount. Why to do all of those things? And coming to rewards structure, person who does first is will get coins, a little transaction fees. Coming to, yeah, this energy consumption is very high, too high. Coming to proof of stake, it's an alternative because proof of work is given a lot of energy. Here, the validators are chosen with the amount of cryptocurrency they hold and they are willing to stake. As I told you that this much is there, so I want to do it. So working mechanism is, there's no competition here because validator is selected from chosen people who has more amount of cryptocurrency, and they validate and they add it to the block. So here, to control it, you should have suppose I told you in Bitcoin you have 21,000 coins. So you should have approximately 11,500 coins. That is, okay, 501 coins or something like that. So 51% of the cryptocurrency you should only have. Then you can control everything. Coming to reward structure, you have no reward. You will have transaction fees. And energy consumption is low because there is no competition at all. Next is, what is crypto assert? Crypto assert is nothing but digital or virtual asserts that use cryptography and blockchain technology. That is the hash algorithm, which is very complex, and the blockchain technology, which is adding linearly the transactions. So these crypto assets can be sold or exchanged as well. Now, what are they? Different types. First one is stable coins. That is, private entities basically create them, and they will keep a backup with fiat currency. Fiat currency means the currency which we use. Suppose I am a private company, I will create a stable coin. I will put assurance that it is backed up by Indian rupees, and I will sell it. And next, coming to security coin or tokens. So it will represent that you are a owner of certain stock or certain bond. Coming to assert coins, it will represent ownership in real estate or gold. That is something which is physically present. Coming to utility tokens. What is a utility token? You have your debit cards and credit cards, right? So whenever you do more shopping, you will get rewards. And with that rewards, you will have access to certain airport lounges. You can go and eat for 25 rupees where other people without them have to pay 1200. So it will access to a service or product within a blockchain system. So this debit card and credit card, I've given an example. So utility tokens are something where you have a percentage of special access to those products. And next one is non-fungible token. What is a non-fungible token? This is a news, so listen to it carefully. So they are digital assets. Suppose I composed a music. It is not physically present, no? You cannot catch your music in hands, no? So that is where I will go and put it into non-fungible tokens. So my music is put into non-fungible token. From there I can sell it. But whenever you put it into non-fungible token, there is a certificate which is generated on your name, that is certificate of authenticity, that it will say that this music, no matter what, you are putting it in blockchain, no matter how much tamper you do, everybody will know that this song is made by you only. Okay, that is non-fungible token. So what is fungible? See, fungible means it has a value to exchange. So I have 100 rupees. I can go to my mother and say, okay, you take this 100 rupees, you give me the note you have. So I can exchange 100 to 100 because my value and her value of the 100 rupees are same. But you cannot exchange non-fungible tokens because my music can be of some value and your painting can be of some other value, right? So you cannot exchange both of them because they have different unique values. Oh, I hope I'm clear. And coming to crypto, last crypto, I mean, there are many, but today we are seeing the last crypto asset is cryptocurrency. Cryptocurrency is also a part of crypto assets only. But what is it? It's a digital currency based blockchains. So here it is actually satisfying three uh, rules of money. That is, it is of transaction and the other two. So, did any time these crypto assets have regulations in India? Yes. What are they? First one is in 2019, RBI declared that cryptocurrency is illegal and whoever has it have to pay 10 lakh fees. In 2020, Supreme Court nullified the ban, saying that oh, this is not correct, you cannot put a ban like this, you see your terms and conditions and change some rules. In 2022, 30% tax got imposed. So whenever you're doing a transaction and if you're getting profit, 30% will go to government only. In 2023, what happened is the G20 actually adopted the Delhi's declaration for effective regulation of crypto assets. So Delhi has declared that we need to have a strategy for regulating these crypto assets. So yeah, coming to this cryptocurrency, I'll tell you, it is satisfying the three major things of three major principles of money. And why is it being so famous? Because as more competition is going into it, the more value it is generating. So, as I told you, the example blockchain, it was there from Bitcoin, it was there from 2009. Initially, somebody with 10,000 Bitcoins bought a pizza. But today, if you are having 10,000 coins, I don't know. I will settle and I will sleep every day. I will enjoy my life. Okay. The currency, so it is becoming a point of investment. So what happens is here. So in order to generate cryptocurrency, you will use the things like proof of work and proof of stake as explained. For permissioned authority, you have proof of authority as well. So here what happens is somebody will pick a person and he will only validate all the transactions. Okay, so this cryptocurrency is generated using point of work and point of stake. Sorry, proof of work and proof of stake. And then now we have applications where we are buying cryptocurrency. So do you think if I mined cryptocurrency, I am going and selling it in the app? No. So I will give all my cryptocurrencies to one person. All the other persons will also give it to one person. That person will create an application, or else I will sell to a person who already has an application and I will say, okay, you sell them, you take little fees, I will take the remaining money. Okay, like that the distribution is there. And coming to maintenance, digital ledger technology is the maintenance for cryptocurrency. Finally, what is national blockchain strategy, which we have right now, because as India is continuously regulating the laws, so they have developed a national blockchain strategy, which is they want to establish a blockchain infrastructure. They want to use the blockchain in different government services like voting, healthcare, education, land records, finance, etc. They want to encourage and startups and innovations which uses blockchain. They want to focus on skill development. Like everybody should have knowledge in blockchain technologies to get their jobs done. Even they want to do it in the research and innovation. They also want to do a cross border applications. Okay, and then coming to blockchain news, in 2021, El Salvador was the first country to use Bitcoin as a legal tender. Like as we are using rupees here, those guys can use Bitcoins. Ethereum. So just like Bitcoin, there's a coin called Ethereum. So this Ethereum shifted from proof of work to proof of stake. So earlier to get that Ethereum coins, mining used to be done. Now it shifted to proof of stake. That is why proof of stake is also important. As you learned, remember that. So merge is a software which shifted it from proof of work to proof of stake. Next, Wazir X launched a NFT marketplace, the non-fungible token marketplace for Indian scientists. So they can go and pledge their, you know, their works over there. And coming to European Parliament, it has given a legislation which is markets and crypto assets, which regulates the framework of crypto services, focuses on crypto assets that are currently unregulated. The subcategorization of crypto assets, as I told you, asset tokens, utility coins, all of them, you will have a key focus. And Bitcoin halving, as I told, after every 4 years or as the competition is increasing, the Bitcoins get halved. That is, the reward gets halved. So, Bitcoin halving is soon predicted. We'll see if it gets halved. So, if you're till here, thank you a lot. Now, for all of these things, I have included notes called Connecting the Dots. So, it is like for quantum technology, there's a paper called Connecting the Dots. So, I have written everything here in a crisp format. What you do is, after understanding all the concepts, you can write this notes simultaneously while listening. Even after that, you take these papers, Connecting the Dots paper, and you read it. Now we are doing prelims, so you need prelims revision papers. So this notes is revision for prelims. Once you revise it, you start solving the questions. I will give you emerging technologies PDF questions once all of emerging technologies are completed. So this will be your point of revision. So in order to reduce your burden, because it's already being time, I am giving you Connecting the Dots papers for each topic. Revise it. Where will you find it? You will find it in a channel called UPSC with VAR. And also the next class would be day after tomorrow. That's it. Thank you. Like, share and subscribe to my channel so that we will get into more aspirants. Thank you. Have a great day. Bye bye.